So our topic for today is two-column proof and some examples. Given angle 1 is congruent to angle 2. So let's mark that. And you need to prove that AB is congruent to CB. So AB is congruent to CB. So what we're going to do is we're going to start with the given because that's what you're going to work with. So angle 1 is congruent to angle 2 by the reason that it's given. And then I could tell that we're going to use this for proof, and the reason is because if I'm able to establish that angle 1 and angle 3 are congruent, then I can use the converse of the base angle theorem to prove that side AB is congruent to side CB. So let's go ahead and do the next statement, and the next statement is going to be that angle 2 is congruent to angle 3, and that's going to be by the vertical angle theorem, or you can simply say vertical angles are congruent. Okay, and so now after establishing that these two are congruent, I'm now going to, if I look at this first, hold on, we've not established that yet. But if I look at this, angle 1 is congruent to angle 2, and then angle 2 is congruent to angle 3, I can simply say that angle 1 is congruent to angle 3 by the transitive property of equality. And transitive property of equality simply means that if A is congruent to B and B is congruent to C, therefore A is congruent to C. So that is the meaning of transitive property of equality. So after establishing that angle 1 is congruent to angle 3, I can now say that AB is congruent to CB. So number 4, AB congruent CB, and that is by the converse of base angle theorem. So let's review. The base angle theorem states that in a triangle, if two sides are congruent, the angles opposite those two sides are also congruent. The converse, however, states that in a triangle, if two angles of a triangle are congruent, therefore the sides opposite them are congruent. Okay, so for our next example, triangle ABC is equilateral, which means that AB is congruent to CB and also congruent to AC. So these three sides are congruent. And then another given is that angle 1 is congruent to angle 2. So these two are congruent. So let's begin our two-column proof. What we're trying to prove is that angle ADB is congruent to angle CDB. So let's begin with the given. Let me put triangle ABC is equilateral, and that is given. With that said, my second statement is going to be AB, which is this, is congruent CB and is congruent AC. Alright, and that is by the definition of equilateral. So the next statement I'm going to make is that angle 1 is congruent to angle 2, and that is given again. Well, first of all, let me discuss to you my plan of action on this one. What I'm trying to do is I'm trying to prove that this angle ADB is congruent to CDB. What I can do to prove that is I'm going to use the congruence of triangles postulate. So there are three postulates: the side, 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 angle, side, and angle, side, angle. As of right now, we have already established that one pair of sides are congruent and a pair of angles are congruent. So I'm kind of thinking that these two are the ones that I'm going to use. However, instead of using angle side angle, which will be angle side angle, which I can also use because those are the base angles of an isosceles triangle considered here to be. I can also do that. However, I want to go to this route of using side angle side, which means side angle and side DB congruent to side DB congruent to itself. That way, I will just be using the reflexive property as my reason. Therefore, I'm going to make my fourth statement, which is going to be DB is congruent to itself, DB, and that's by the reflexive property of equality. Okay. And then after doing that, I can now establish as my fifth statement that the triangle ADB is congruent to triangle CDB, and it's because of the side angle side postulate. Because of these two triangles being congruent, I can now say that angle ADC is congruent to angle ADB. ADB is congruent to angle CDB because the corresponding parts of congruent triangles are congruent, better known as CPC-DC.